Wissenheim is a remote place way out in cyberspace, dedicated to learning, science and research. Two unicorn scientists enjoy the pure waters of Wissenheim Pond, finding knowledge, finding new ideas, talking. But nearby, mistrustingly, other creatures observe the doings of the scientists. Their noises sometimes disturb the scientists, and the view of those animals is obstructed by paragraphs. Big paragraphs for big animals, small paragraphs for little animals. On our journey in cyberspace, I would like to show you a few milestones of the last 20 years of research we have performed. Here you see a computer which has been transformed into a telephone with graphical user interface. You can double-click an icon and immediately the telephone connection is established. You can automatically establish conference calls, you can manage your callbacks. After all, it's a convenient mode of operation of a telephone if you compare it to typical multi-key telephones which are still in use in today's offices. But here comes a call from our friend Siegfried Hefner, who invites us for a little ride on his virtual model railroad. Of course, we will follow him and we will shortly meet him on Virtual Railroad Island. Okay, so it's really my pleasure to present to you distinguished virtual railroad engineer Professor Dr. Siegfried Hefner. In his time at our institute, he has built a model railroad and provided this model railroad to the community on the internet. In the time of operation of this model railroad, we had more than 1 million visitors, and it has been an excellent publicity stunt for our university, but there has also been a lot of technology involved into providing this railroad. The video service has been prepared by Heiner Wolf, and the control software has been written by himself. Today, 70 years later, after Siegfried's virtual model railroad, technology has taken many steps further. We are now on a little virtual model railroad island in the virtual world Second Life, which of course has not been built by ourselves, but which has been built by the Imagine Boys Toys group, a group of virtual railroad fans which have spent a lot of time and effort into creating this railroad. We are now taking a trip on the virtual model railroad of Second Life. Here the train enters the station, and in a few moments we are going to enter the engine and take our virtual railroad train, sitting in the railroad ourselves.
Lord.
Our next station now is in Silicon Desert. Sand, sand, no water, and burning sun. But what can you do with silicon? You all know silicon is typically used to build electronic circuits. And we don't have to look far. We find an electronic circuit. It's probably a microcomputer buried in the sand. We sit on it and think what to do. Typically, people will think about water, how to get water in this desert, how to protect yourself from thirst and the burning sun. And as a matter of fact, we don't have to look far. All of a sudden, water appears. But this source of water, typically people would drink the water, but what does a computer scientist do? He takes the source and compiles it. And here you see a small Java compiler developed by Stefan Frenz. He takes the source and compiles it in the module which is being loaded onto the microcircuit. And this small Java compiler is a very fine tool for programming little computer circuits. Here we see more precisely the internal operation of the small Java compiler built by Stefan Frenz, which has not only been used for programming small microcontrollers, but which has been used for programming larger cluster computers. As an Institute for Distributed Systems, we were committed not just programming small computers, but programming complete distributed systems. And in our next step, we will consider distributed systems. Distributed systems of the cluster type. Now, you see that little terminal? This little terminal will allow us to create a little PC cluster. This PC cluster consists of 4 PCs, could also be 200 PCs, which are supposed to cooperate within the same software system. To cooperate, they need a network which connects them. They also need keyboards and terminals and screens, so the individual machines can be used productively. And in order to perform our experiments, we had to install some control, measurement software, a measurement and monitoring station, which will tell us what happens within the cluster. Cluster computing systems have been built in many different variants. Our special goal has been to build a simple, efficient and quick starting cluster environment. The cluster we have built is able of starting within less than 1 second. We have now built a bridge from the pure hardware way over to sophisticated software concepts. We call it the rainbow concept. Here you see the rainbow leading from the physical hardware of the cluster to a very sophisticated, novel operating system. The concept of operation of this new operating system is symbolized by the little object you see here. In the center, dark green, you see a common memory which is shared by all the 7 stations which cooperate in our cluster. It's called distributed shared memory. Another station on our journey is Wissenheim Educational Objects. Here we see an educational object which explains the structure of a flip-flop, a binary storage unit. Or another educational object we will examine is a binary counter. Please observe the carry mechanism which allows to propagate the sum from right to left. Another more sophisticated educational object is a pipelining computing engine. We will observe the pipelining computing engine in a few moments. It has already rest at our left, and let's observe. We have 5 stages. At the top, at the left, new instructions emerge, and they are slowly propagated from their start to their completion through the various stages of our pipelining processor. New instructions at the left, old instructions will exit at the right. There is a concept which has proven to be hard to grasp for our students, which is holding the pipeline. We press the first button and the first half of our pipeline stops, and the second half empties until the pipeline is restarted again. A second mechanism, which must be distinguished from the first, is the flushing of the pipeline. We exemplify this by pressing the second. Now we are back on Wissenheim again, and it is time to release the ropes and go to new shores of activity. Here are the ropes which will be attached and then released again. A somewhat sophisticated cyberpunk aeroplane airship is arriving, and we are pleased to board it in a minute. The engines stop. Thanks you for visiting Wissenheim so far. I now take the opportunity to say goodbye, and I'm looking forward to see you again when I'm back from the faraway place. Now, just too bad you can't hear the sound of the engine, but the engines are powerful and will carry us far across the ocean eventually. Detach the ropes and go to new shores of activity. The journey across the ocean is rather long. We will spare it for you. We have cut it out from our movie sequence, and shortly we will arrive in Wissenheim of Arabia. Through some clouds still, taking some corners. Here is Wissenheim of Arabia. Carefully we take our landing approach. Camels, must be Arabia, must be the desert. We hope it's not too hot outside. Okay, engines off, and we have made a safe landing. We step onto the new land, and not far from here we are greeted by the new dean of the Teacher Training College in Riyadh. While we are on the send, our ship flies back home. Thank you for attending our little journey in cyberspace. It would be our pleasure to welcome all of you one of these days in Riyadh at the Teacher Training College. Give us a call. Either you visit us in Second Life or you visit us physically in Saudi Arabia. It would be a real pleasure visiting you in Second Life, but even greater a pleasure having you as a visitor in Riyadh whenever possible. Thank you.